Let us now study the RMS value of AC. Okay. So RMS means what? It means a root mean square. Okay. RMS. That means you see what is it now. So the root mean square value of an alternating current is defined as the square root of the mean of the squares of all the currents, okay, over one cycle. Okay. This is the definition here. We'll see how it comes. Okay. So for the RMS value of currents we say IRMS. Okay. For alternating voltages we say VRMS. Okay. Now we know the equation I is equal to Im sin omega t. So this is the equation for the current here. Okay. Now we can also write this equation as I is equal to Im sin theta. Okay. Why? Because theta is equal to omega t. Okay. Now let's go to the picture here. Then we'll come to the next equation. Okay. So in this picture you see it's like this way now. Okay. So I've drawn this thing here. Okay. I is equal to Im sin omega t. Okay. I've drawn this wave here for that. So 0, pi, 2 pi. This is the angle theta, and then we have current I. Okay. Now we must take the square of this current here. So this is say plus 0.1. Okay, you take square here. Okay, and you take all the squares of the positive numbers. So that square is 1, so I will draw like this way. Okay. And if you take negative square will become positive only. Okay. So that curves also will be coming like this way. So this dotted line says a squared wave. Okay. So we say this will be the I square wave. Okay. So current squared. Okay. Now what we do now, we take a small element here. Okay. We take a small element. This is a small element here. Okay. We take the small element here like this way. Now this is the mid part of the small element. Okay. Corresponding to that. Okay. That we take as I. Okay. Actually on the y-axis also we have I here. Okay. And in this side. Okay. So corresponding to the small midpoint of small element we see that is the current I here. Okay. Not I square here in this case. Okay. In this case it will be I square. Current was I and this will be I square. Okay. Because the dot lines are I square only now. Okay. And this distance here from here to here. Okay. This distance we say it as d theta. Okay. This distance here, the distance of the elementary strip. Okay. Now let's go to the definition and see equation here. So IRMS is equal to root of area of one cycle of squared wave divided by base length of one cycle. Okay. So area of one cycle means what? This one crest and one trough. That makes one cycle. Okay. So you must take this area of one cycle of squared wave. Okay. So this is squared wave, dot lines. Okay. So one cycle means it will be having this part and this part. So from here to here you must take this full area, okay, divide by the base length. Okay, so divide by this length here, that will be 2 pi. Okay, so you must take this one's area and this one's area, divide by this 2 pi here. Okay, so that will give us the IRMS. Okay, so let's derive and see how to get the equation for this IRMS. Let me erase the board now. Okay, now I erase the board and I have written the equations like this way now. Okay, so this was the equation for the current here I. Okay, and I written in theta. And this was a value for the IRMS. Okay, this we taken as equation 1. So let's take the area of this element here. Okay, so I said this thickness was d theta. Okay, so let's see the area of the element here. Area of the element. Okay, so it's like a rectangle here, length into breadth. So length is I square, breadth is d theta. So get here I square into d theta, length into breadth. Okay, that's for this small element only. But now you must take this full dot lines now. From here to here you must take the full area you must take. Okay. So for that what you must do, you take all the elements here like this way. Imagine that it has many number of elements. You have to add all these things. So addition we say, integration we use. Okay. So area of this one, that is one cycle of squared wave. Area of one cycle of squared wave. Okay. So for that what you do, integrate this I square d theta. That means this element here. Okay, like this is that many small limits. Okay, from limits you see starting limit is 0. Okay, and the ending was 2 pi. Okay, so that's how we get the limits here, 0 to 2 pi. Okay, now what you must do, you substitute the value of I here. Okay, this one. Okay, substitute, you see. Substitute the value of I. Small I here, substitute in C. So what you get here is integral of 0 to 2 pi, okay, instead of I square, okay, I, okay, instead of I you write as Im sine theta and then square, okay, d theta. Okay, so square this term. So what you get here is integral of 0 to 2 pi. Okay, so we take here Im square, okay, sine square theta d theta. Okay, now Im square is constant. Okay, so we can take it out. Okay, Im is what? The mean value. Okay, or the maximum value here. Sorry, not mean value, maximum value of the current. So we have here Im square will go outside. Integral of 0 to 2 pi sine square theta d theta. Okay. Okay. Let us see what is this sine square theta means. Okay. So we know that cos 2 theta is equal to 1 minus 2 sine square theta. Okay. So you must get this, what's the value of sine square theta. So take this 1 to left side, become minus 1. So minus 1 plus cos 2 theta is equal to minus 2 sine square theta. Okay. Now you must get this minus sign outside. So multiply by minus sign. Okay. Multiply by minus sign everywhere. So multiply, so what you can see, you get plus here, plus 1 minus cos 2 theta is equal to 2 sine square theta. Okay, bring this 2 downwards here. So we get here 1 minus cos 2 theta divided by 2 is equal to sine square theta. Okay, so that we can substitute now. So what you get here is Im square into integral of 0 to 2 pi. Okay, this is Im square here. Let this square this side. Okay, into 1 minus cos 2 theta divided by 2 into d theta. Okay, so this is how we get it. Okay, so this term you can write in brackets also. Okay, now this 2 is there now. This is a constant. Okay, half that we can take outside. Okay, let me rub the left side and right down. So I erase the left side. Let me go now. Okay, so what we get here is Im square divided by 2. Okay, into integral of 0 to 2 pi. Okay, and then we have 1 minus cos 2 theta into d theta. Okay, is that now you can multiply d theta inside here. Okay, you go step by step, then it's very simple. So Im square by 2, okay, integral of 0 to 2 pi. Okay, so multiply d theta inside, so we get here d theta minus cos 2 theta d theta. Okay, multiply d theta inside here and then inside here also. Okay, so now this integral is done. You can split the integral, right? Okay, that's more easier to do. So what you get here is Im square by 2, okay, integral of 0 to 2 pi d theta minus, okay, integral of 0 to 2 pi, okay, cos 2 theta d theta. Okay, so this is common here. Okay, so we get here Im square by 2. Okay, integral of d theta will be theta only. So we get here theta. Okay, from the lower limit is 0, upper limit is 2 pi. Okay, minus the second term. Okay, let's see what is the second term here. How to write this term? Okay, cos 2 theta. Okay, let me erase the right side now. Okay, so there's a formula integration. Okay, it states that integral, okay, of this cos ax is equal to 1 by a sine ax. Okay, so this a is a cos ax that you must bring down. So here it's, let's say, cos ax. Okay, 2 is the a here. You can bring the 2 down. Okay, so let's see what we get here. Okay, when you solve this 2 will come down. That is half into and then sine ax now. So we get here sine this ax, that is 2 theta, from lower limit 0, upper limit is 2 pi. Okay, you can see the limits are common, so you can group them together. Okay, let me write it down. So what you get here is Im square by 2, okay, theta minus half into sine 2 theta from limit 0 to 2 pi. Okay. So now we can substitute in C. Okay. Let me draw a line here. It's 2 pi this side. So let me rub this thing. Okay. So let's solve this now. So what you get here is Im square by 2, okay, into, instead of theta you substitute upper limit here, that is 2 pi. Okay, so 2 pi minus, okay, this half into sine 2 into 2 pi. Okay, so instead of theta you substitute this one. The next one minus, okay, the lower limit here. Lower limit is 0. Okay, so 0 minus half into sine 2 times 0. Okay, that will be sine 0 only. Okay, now let us see what we get here now. So 2 pi we write as it is. So half, so Im square by 2 into 2 pi. Okay, you write as it is. Okay, and then minus half sine of 4 pi. Okay, sine pi means 180. Sine 180 is how much it is? 0. Okay, so this full term will become 0 only. We get 4 pi, that is 0 only. Okay, so this term becomes 0. Okay, minus all these terms. Sine 0 is 0. Okay, so this term is 0 here. So only term remaining is 2 pi only. Okay, so what we get here is, and right here now, so we get Im square by 2 into 2 pi. Okay, again 2 and 2 will cancel, so we get here Im square into pi. Okay, so this is the value we get here now for the area. Okay, let's substitute in equation 1. Okay, substitute in equation 1 for the area. Okay, so remember the rule, this one, there is a rule here. Okay, that is Irms is equal to root of area of one cycle of squared wave divided by the base length of one cycle. Okay, so that's the equation here. So Irms will be equal to, okay, root of, okay, this one's area, that is Im square, square here term here, square pi, okay, divided by the length here. Actually, if you see, this was a graph we got. Okay, it was like this way. So 0 to 2 pi. Okay, so the length of this graph was 2 pi here. Okay, so pi and pi will cancel here. Okay, let me erase this thing. So what you get here is value for Irms. Okay, I'm continuing from here to here. Okay, so you get here root of Im square divided by 2 pi. Okay, 2 only. Okay, so what happens is, so Im square root, okay, you can take root. So we get here Irms is equal to Im, okay, divided by root 2. Okay, now let us see what is 1 by root 2. We get here 0.707. Okay, so we get here Irms is equal to 0.707 Im. Okay, this 7 here. So this is the value for the Irms. Okay, now you can see here Irms is equal to 0.707 Im. Okay, let me plot this thing. Okay, and same way we can also say that Vrms, similarly Vrms is also equal to 0.707 Vm. Vm is what? The maximum value of the voltage. Okay, so these are the two equations for the root mean square value of AC. Thank you for watching.